All right, guys, I hope all is well with you. Let's just get going right away. We are going to be discussing question 4. And question 4, let me share with you right away on the screen so that you can have a copy here. But in case you do have one with you already, it's also fine. You will be looking at it while we discuss this. Okay, there we go. Yeah, so question 4 is right here. Broken into 6 parts, like 4.1, 4.2, 4.3, 4.5, up to what? Up to 4.6. So yes, we have been given the function f of x. This function f of x equals 2x cubed minus 23x squared plus 80x minus 84. The thing we have to do is to prove that x minus 2 is a factor of f. So any idea how we can prove that? Any suggestion on how we can get this proved? Would you like to say something about how we can prove this? Well, to prove that a given expression, in this case x minus 2 is a function, rather is a factor. That means if we substitute the value 2, okay, in this expression, then we will get what? We will get 0. This is actually what I'm trying to say. Let me create a page right away where we can get started with our discussion. Right, so let's start it right here as 4.1. So we have to prove that the function f of x, okay, can be divided and it will give no remainder if it's divided by x minus 2. So this is what we are dealing with. We have been given f of x, and f of x is what? Is 2x cubed. That is 2x cubed. And minus 23 x squared minus 23 what? X squared plus 80x minus 84. That's what we have been given. The expression given here, the additional expression, is x minus 2. And what we are supposed to do is to prove that x minus 2 is a factor of the function. Now, to prove that, we first have to solve x minus 2. So we'll be like x minus 2 equals to 0. Okay, we have to solve that x minus 2 equals to 0. Now here, when we solve, what do we get? Well, we get the value of x, and x in this case is equals to 2. So we go ahead and put x equals to 2. This is what we have got so far. Now, okay, so after finding the value of x, we can now go ahead to substitute 2 for x in the expression. So what we are going to be having in this case is that we have to put 2 in the expression for f of x. In other words, f when x is 2 must give us 0. So if f of 2 can give 0, then we can conclude that this expression, or x minus 2, is a factor of what? Of this expression, 2x cubed minus 23x squared plus 80x minus what? 84. All right, so now from here, we can go ahead to check. So let's get right away into this. So we'll be having f of 2 now equals to f of 2 now equals to the expression we are dealing with is this. So this is where we have to substitute 2 for x. So where there is x, we write 2. So let's check. Can copy this. That would make things a little bit faster. Otherwise, 2x cubed would be the first term to be written down. Well, it's not accepted. So there we go. We now have to write 2x cubed. So this is 2x cubed. 2x cubed minus what? 2x cubed minus 23x squared minus 23x squared. Okay. Then the next term is 80x minus 84. So 80x is there minus sign or plus? It's plus. Okay. Plus 80x minus what? 84. Yes, that's what we have, and that's what we have to be dealing with. So now f of 2, we start substitution right away here. We'll be having what? We'll be having 2 for x. Then here we'll also be having 2 for x. Then lastly, we'll also be having 2 for x in this. Like that. And let's see what we get. So you got a calculator with you over there. Just do that calculation and let me know what you have got. You know, this is like 8 times 2, 16. Then we have 23 times 4. Now that needs you to be having a calculator. So make sure you do have one. So this is 23 times 4, which gives what? 92. So we say minus 92, then plus. This is 100 and what? 60 minus 84. Let's see what we are going to get for that. So this is going to give us the whole thing now, 16 minus 92 plus 160 minus what? 84. What have you got? I got 0. I guess that's what you've also got. So yes, this is how we prove, okay? So when a question requires you to show that an expression is a factor of a given function, you first solve for x in that what? In that factor, the way we did it here. You know, the first step was for us to solve for x, and we got 2 for x. So now we have to substitute this value 2 in the expression for f of x, which is write this. So when we substitute 2 for x in this expression, what we get, as we have calculated, is 0. And that shows that the function f of x can be divided by x minus 2. In other words, x minus 2 is a factor of the function f of x. Okay? Well, the next question is, it's what? It's 4.2. So the next question is 4.2 right away. Let's see what they're asking for in 4.2. So in 4.2, we are supposed to factorize f of x. Okay, we are then supposed to factorize f of x. Hence, or otherwise, after proving that x minus 2 is a factor, we then have to do what? We have to factorize that. So how do we factorize this? Well, we then have to divide this expression by that. Okay, so let's see how we can do the division. In other words, to factorize, okay, that is to factorize. The first step is to divide the original function by x minus 2. And what's the original function? The original function is 2x cubed, okay, 2x cubed minus 23x squared minus 23x squared, okay, then plus what? Plus 80x minus what? 84. That's what we have. So to factorize these things completely, what we have to do is to divide the whole of this by x minus 2. So how do we divide this whole thing then? How do we divide this whole stuff? Now, unfortunately, what I'm going to do is to change a little bit the page, because we have to do some drawing. So let me just create a new page here where we can do the calculation. So what we are going to do is to do some drawing. There are two methods. We can use the method of long division, or we can use this method here called synthetic, okay? Synthetic division. So this is what we have. We'll draw this. Then this quantity that we are dealing with, okay? These ones here, the numerator, just do some snipping here real quick so that we don't be referring to that all the time. Here we go. There we are. Okay, so this is the page that we are now going to be working on just a little bit. And this is what we are dealing with. Yes, this is what we are dealing with. Just put it right over here. So the thing now we have to do is we calculated x and we got 2 for x. So we'll be writing it down here. We say 2 is the value of x that we have got. Let's make it a little bit big. Yeah, there is something I need here in text. Just delaying to come. Yeah, but it should be coming. I just want to make the font a little bit big. It's taking a little bit long to respond, but it will obviously respond. Let's put 28 here. That's what we are dealing with. Yeah, so there we go. Now, we'll be putting these 2 right out here. Then inside, we put the coefficient of these numbers we have here. So what are they? Well, the first being 2, the next being minus 23, then followed by what? 80. Then we also have minus 84. Okay. Now that's what we are dealing with for now. Okay. So here we have 0 for now. 0 for the start, like that. Now, when we add 2 to 0, what do we get here? We get 2. So we write it right there. Okay, that's what we have got. That is when we add this 2 to this 0, we get 2. Then now we multiply this 2 by this 2 and we get what? We get 4. We put it here. Right under 23. Then when we add this 2, negative 23 plus 4, let's check. 23 negative, when you add to 4, what you get is negative 19. So we put it here, negative 19. Okay, write down here. Then after that, we multiply this 2 by this negative 19. So what we get when we multiply that by 2 is negative 38, which we put here, negative 38. So negative 38, right under negative, right under 80. When we add negative 38, okay, when we add negative 38 to 80, what we get is 42. So we write it as 42 right here. Okay, then after that, we are now dealing with 2 that we have to multiply with 42, so that we get 84. And we write it here right away. See, so when we add these 2, what do we get here? We get 0. This is the remainder. All right. So just really quick, this is what was happening. Just do this. This one, we don't need to have it there. All right, so what I was doing is this. Step 1, you know, using this method, this synthetic division. Step 1 is to take the coefficient of this number here that we are dividing. Okay, this expression, you take the coefficient of the what? Of the x. So you start with this is the coefficient of x cubed, you write there. This is the coefficient of x squared, you write here. This is 80. 80 is the coefficient of x, you put it down, and then you write constant. The constant is negative 84, you put it there. Now from x minus 2, we had solved for x. And after solving for x, what did we find? We got 2 for x. You put it out. There is nothing to write here. So you can either just leave it or you put 0 and you write the 2 down here. Now, the first thing you want to do is to multiply this 2 by this other 2 so that you get 4. You put this 4 here. Okay. Then after that, you add this 4 to what? To negative 38. That way you get negative, rather this is negative 23, not 38. So negative 23 added to 4, we get negative 19. Then we multiply this negative 19 by 2, so that we get negative 38, which we later add to what? To 80. So 80 plus negative 38 gives 42. Then again, you multiply this 2 by 42, so that you get what? So that you get 84, which you write under 84, which is negative 84 up there. So you add this 2 and you get 0. Now, what we have got here is that when this expression is divided by x minus 2, the coefficients will be 2 negative 19 and 42 with a remainder of 0. Okay? So in other words, it's like trying to say, when you divide 5, say by 2, you get 2, the remainder is 1. In this case, the remainder is 0. So it's like you divided 6 by 2, or maybe 5 by 5, you know, without what you have got is a number without a remainder. So how do you then express it? How do you then write this? Well, we can then say this quantity here divided by the other one will give us this, with these numbers representing the coefficient. And so let's put it right here. So we'll now be having this 2 equals to what? Fortunately, I've got to again type the whole of this thing down. So, well, let's just get it going. So we have 2x cubed, 2x cubed minus 23x squared. Okay, then plus 80x, then minus 84. So what we are doing is we are dividing this by x minus 2. Okay, x minus 2. So that we get, well, what we are going to get is what we have written here. So we have 2, negative 19, and positive 42. Okay, 2, negative 19, and positive 42. All right. So with this one being the coefficient of x squared, this one being the coefficient of x, okay? And this other one, 42, being the constant. So 19 is the coefficient of x, and 2 is the coefficient of what? X squared. We put it right down there, x squared, like that. Yes, so that's what we have got. So now the question is that we factorize this expression here. So as we indicated, to factorize that, we have to divide this expression. What we get in this case is going to be, all right, looks like the screen has, that I'm sharing, looks like the screen has disappeared. Let me bring it right back. There we go. Okay. So yes, the screen is now readily available there. So what we did was to divide this quantity here, this one, by x minus 2, and this is what we have got. Now, after finding this, the question is, can we go ahead to factorize that? Because now we can write this expression here as a product of this other one times the divisor x minus 2. This that we have got is called the what? The quotient. This other one is called the divisor. So we can now express this as a product of x minus 2 times that. We will have done partly the factorization bit. We are supposed to factorize. How do we then conclude the factorization? Well, we will have to check if this one here, if this can also be factorized. Okay, so let's just write this down. We'll be having 2x cubed, that is 2x cubed, minus what? Minus 23x squared, 23x squared, plus 80x, okay, plus 80x minus 84 can now be written as the product of what? X minus 2 times this other one here, which is 2x squared, 2x squared there we go, 2x squared minus 19x plus 42. Yes, that's what we have got. And just try to reduce the font size slightly so that it can fit well there. Yeah, so this is what we have got. Can we go ahead to factorize this? Yes, we can go ahead to factorize this quantity here. And let's do it. So doing that, we'll now be having 2x squared equals to what? Rather 2x squared minus 19x. This is 19x plus 42 equals to, well, you know, we could use this method. So would you like to try this out? And you tell me what you have got for these two. I'm just going to give you the answer right away. But if you struggle with this, then the first step, okay, question here. Yes, yeah, here is the question that if we factorize a cubic function, okay, this is the question which is coming up, that if we factorize a cubic function, isn't it supposed to have 3 brackets? Yes, a cubic function must be factorized to give 3 brackets. The first bracket is this other one here, x minus 2. Now, this is the second bracket, which we must now factorize again so that we have what? 2 more brackets. Now, these 2 more brackets will replace this one bracket here, so that we will now be having 2 brackets there and another bracket here. Okay? So to your question, yes, a cubic function must have what? 3 brackets. In other words, a cubic function will have 3 values of x. Now, the thing I need you to do right there, as I requested you a little bit earlier, I said, you know what? You've got to have with you a piece of paper and a pen. So please factorize this expression here. I'm going to be waiting. I just want to put the value here and there so that we can conclude that this, which we have written here, can be factorized into this times the 2 brackets you will have given me for this one. So yes, please go ahead and do that. Go ahead and do that real quick. Factorize this expression here into 2 brackets. Then tell me what you will have got. I will be typing this. Okay, do it. Then you tell me what you have got. What have you got here? Well, you must have got 2x minus 7 and x minus 6. Okay, that is what you must get. 2x minus 7 and x minus 6. Like that. This network is really becoming a problem. Why is it like this? I hope you can. I think the screen is gone. Let me just bring it right in front. Okay, so yes, this is what we are dealing with. Factorizing this will give us these two values, and so we can substitute them right inside here, so that we have for the first bracket x minus 2. The first bracket will be x minus 2. Then the second bracket will be what? 2x minus 7. Then the third bracket will be what? X minus 6. Like that. So those are the what? The three values. Those are the three values or the three brackets. Now we are done with 4.2. We can now go to 4.3. Okay. If you would like to have a little more practice on this part of factorizing or this method of dividing things here and there, then I would give you just a number to try. If you can go ahead and just try this out, okay? This is for you to try. Let me see it right here. A question? Yeah, here is a question that does it matter if x has got a coefficient in the bracket? Now, how will you have factorized in this case? If you don't get it that way, how will you have factorized? Yeah, x should be having a coefficient inside the bracket, but it's because factorizing this quantity here, unless you just solve for x and now you are looking for a way of bringing it to a factorized form. Otherwise, step 1 to factorize is to multiply 2 by 42. Then you look for two numbers that would give you what? A product of -19 and a sum of 84. Those two numbers would be what? Those two numbers would be the numbers you would substitute for what? You would substitute for -19, and then you will simplify them. So yes, just familiar yourself, get used to the method of factorizing. Solving is also good, but it's important to have the coefficient of x inside. It's important to have it right inside there. Now, if you find some time later, possibly, then I need you to try this out. There is this question, which is what? Which is x cubed. I'm just going to put it really quick. X cubed plus 2x squared. Okay, x cubed plus, oh, not like that. X cubed plus 2x squared, 2x squared. All right. Minus 6x minus 9. That is minus 6x minus 9. Okay. I need you to try that. Try it how? By dividing. You try to divide this by x minus what? X plus 3. You try to divide this by x plus 3. Yeah, do that right away. Some other time, possibly later, just to get used to how to deal with this type of crisis here, so that we can move to 4.3. What is 4.3? Question 4.3 requires us to determine the coordinates, the x coordinates of what? Of the stationary point. the function f? Well, the stationary point is this point, rather is the point when the function is not changing. Now, the function does not change at the turning points, when it is curving either up or down. That is when we say the function is not changing. The word stationary here means not changing or not moving. So when is the function not changing? The function is not changing at the turning point. Okay? And remember, this is a cubic function. If it was a quadratic function, we would use the expression x equals to minus what? Minus 2b over, rather minus b over 2a. You see, we would use that expression x equals to minus b over 2a only if it is a quadratic function. But this is a cubic function. And since it's a cubic function, how do we get the stationary point? How do we determine the stationary point? The stationary point is the turning point. And so we are going to differentiate. We will have to find the value of the y by the x for this function. And when we find the value of the y by the x for this function, then we say that derivative at the turning point, the derivative is 0, because by dividing the y by the x, we will be finding out the gradient, okay? The y by the x is the gradient, and gradient is the rate of change. It's like the slope. And so the slope is 0 when there is no change. So that then means we have to differentiate f of x. And when we differentiate f of x, we get an expression for the gradient. The expression for the gradient, we make it equals to 0 because at the turning point, the gradient is 0. There is no change in the function. The function is not climbing up. The function is not sloping down. There is no change. So because of that, let's go ahead and do what? And differentiate. So what would be the derivative of this function? Well, we have this function here that we have to differentiate. And so we say the derivative of this function, or at the turning point, or simply at stationary point. At that point, the stationary point, the derivative of this function, that is f prime x, is what? 0. There is no gradient. The function is not climbing up. The function is not sloping down. It is turning. It's like making a U-turn, okay? You see, if you're driving forward and for some reason you discover you first need to come back home, or you need to drive to make a U-turn. As you are making the U-turn, at that point when you are driving and making a U-turn, you are not moving forward and you're not moving backward. You see that? You're not going forward, you're not coming backward. You're just making a U-turn. It's like you are at the top. And so there is no change in speed, for example. Rather, not speed, but there is no change in you going forward or coming backward. And that is where we get the what? The value of the y by the x equals to 0. And so when we differentiate this one, what do we get? Well, when we differentiate 2x cubed, we get 6x squared. Right here. Then the next thing is to differentiate negative 23x squared. That gives us what? 46x. So you'll be writing 46x right away here, minus 46x. Now, after determining the value of that, we go ahead to differentiate 80x. So we say plus 80. This constant is 0, and we later equate it to 0. So now here, we can go ahead to find the value of x. The value of x that we are finding from here will represent the x-coordinate of the turning point or the x-coordinate of the stationary point. Now, we will find two values for x because this is a quadratic function. And so that means the function f of x turns at two different points given by the two values of x. So what do we have here? Well, let's simplify this. Now, notice that we could first simplify this expression. Can we divide 46 by 6, or at least there is a way we can reduce this? Yes, let's just divide this by 2, that by 2, and this other one by 2. So when we do that, what we are going to get, just to have a number which has been reduced and easy to deal with, we are going to be having 3x squared, okay, minus what? 3x squared minus 23x plus 40 equals to what? To 0. What we did was to just reduce it, okay? We divided this by 2, by 2, by 2, so that we are having a number which we can easily deal with. So now this way, what are we going to do? Well, the next thing here is to find value of x. We can use the method of factorization, or we can do what? We can just solve for x using the formula. Well, let's use the formula. The method of factorization also works sometimes, but the formula will always solve. So this is what we are going to do. We have to find the value of x from here. So we say x is going to be equals to what? Minus b, which in this case is minus 23. So we just write this. So this is going to be 23 plus or minus, okay, right here, the square root of what? The square root of 23 squared. Just put the value right away. 23 squared, that is 23 times 23, which is 529. Minus what? 4 times a, which is 3, times c, which is 40. That gives us what? 480. Yeah, that's what we have got. Then the denominator is 2 times what? Times 3, which is 6. So yes, we put it down there, 6. So this is what we have got so far. What's the next thing to do? The next thing to do is to simplify that. Well, what is 529 minus 480? That gives 49. And the square root of 49 is 7. So what are we dealing with? We are dealing with the 23 plus or minus 7. Okay, plus or minus 7 divided by 6. Like that. So one value of x is where there is a plus, and the other value of x is where there is a minus. So what is that going to be? Well, one value of x is going to be 23 plus 7, which is 30. 30 divided by 6 is what? Is 5. And another value of x, okay? And the other value of x is going to be 23 minus 7. What's that? That's 16. Okay, is it 16? 23, let's use calculator. 23 minus 7. Yeah, it's 16. 16 divided by 6. 16 divided by 6 is what we are dealing with right now. Divided by 6 right here. That's what we got. We could reduce this, okay? We could write the value as 2.67, or we could reduce it to 8 divided by 3. There isn't a problem writing it as that. 8 divided by 3, or simply 2.67. 2.67. That's what we have got. So the question was asking for, or it's still asking for, the x coordinate of the stationary point. Well, only the x value of the stationary point. We don't need to find the y value. But if it was necessary to find the y value, we would substitute the x value in the original expression. That's all. Next, 4.4. Now, 4.4, we are supposed to make a sketch of the graph of the function f of x, clearly labeling all the stationary points. The stationary points, we already have them. The only thing that we just need to check is the x-intercept and the y-intercepts. Basically, that is all, okay? So, unfortunately, I have not yet installed a program for drawing a graph, but we will see what we can do. We'll just get the what? The x-intercept and the y-intercept and the stationary points. Now, let's just conclude with the stationary points first. What is this? This is 4.3, so we are dealing with 4.4 right now. So 4.4, sketching a graph. Sketching the graph like that. So sketching the graph, the stationary points will be the two stationary points, okay? The first one where x is 5, but we don't have the y value. And the second one is where x is what? Where x is 8/3. Okay, this is 2.67. Let's write 2.67, like that. Then the y value is not known. So let's determine the y value real quick, just a minute. Just a minute here. Yeah, sorry for that. This is what we are remaining with, the y value. So the y value is going to be the value of the f of x when x is what? When x is 5. So there we go. Right away, f of x is going to be f of 5. So what's f of 5? Well, f of 5 needs us to substitute 5 in the original expression. And where is it? The original expression is wait, let's see. The original expression, yeah, is the expression for the function. Yeah, this one here. So there we go. Let's just substitute right away. And we see this is 2x cubed. 2x cubed. Okay. Then after 2x cubed, what do we have? The next is minus 23x squared, minus 23x squared, 23x squared. Okay, then after that, what do we have? We have 40, is it 40? No, we have 80x. 80x, and finally we have 84. That's what we have. So f of 5 is going to be the value of the function when x is 5. So we put 5 there. Then here, we also put 5. Then here, we also put 5. Yeah, so what do we get for that? That's going to be the y value. And what is it? Well, let's get right away with our calculator and we get the value fixed. So if you're calculating from there, you can just send me the value right away. This is 2 with 5 cubed. Then 23 times 5 squared plus 80 times 5 minus what? 84. That gives us -9. Is that what you guys have got? I've got -9 here. Let me just check again if it's the right value. Okay. Yeah, it's still the right value. Then that means here we are going to have -9. -9. Then how about here? All right. So that is going to be f of 8/3. There we go, f of 8/3. So this question was a long one, right? So long. F of 8/3 is going to be equals to what? 2 times the value of times, this is 8/3. But it's going to be what? It's going to be cubed. We have to raise this to power 3. Then the next thing is to add, rather minus 23 minus 23. Then inside there we put 8/3. But we have to do what? We have to square it. Oh, not that. Here. Yeah, we have to square this. Then what else do we have? Plus 80 times 8/3. This is 8/3. Then minus 84. Like that. Yes, that's what we get. And what will the final expression be? Let's see. Final expression is going to be, you can be calculating with your calculator over there if you do have one. In case you don't, then you have to wait for my value. But I just need to check something here. If this value of 5 is what I had got earlier, and this one. But let's do this. This is 2 times, right, 8/3 cubed. 8/3 okay, this is cubed. Then minus, just be careful. I wish you could try this yourself, because a long calculation like this one, when you enter it in a calculator, you need to do it with a lot of care. And I would love to see what you would find out, and if everything would be the same like what we have here. So this is squared, not like this. Okay. Then plus 80 times 8/3. 8/3 minus 84, like that. I've got 3.7, 3,770, you know, like that. Yeah, this is what I've got. Is that what you've got? The question here? Yeah, 3.70. This is true. This is good. So that is the value of f of 8/3. So we can go ahead to substitute it right here. This is 3,7. Put it there. 3,7. Okay. Now plotting this should not be a difficult thing for you guys. If you now have the points, just looking for the x value and looking for the y value, that should not be that difficult for you. Now these are the stationary points. The next thing you don't want to miss is the what? Is the intercepts. So we will be talking about the x-intercepts and the y-intercepts. What do we know about the x-intercept? The x-intercept occurs when what? When y equals to 0. Like that. The x-intercept occurs when y equals to 0. And what is that supposed to mean? Well, that is supposed to mean we find the value of x. But you see, we had already simplified it. So these are the values that we want to deal with. So the x-intercept will be at this point, this other point, and that other point. Okay, that's for the x-intercept, those three values. So we just put them there. This occurs when this equals to 0. And so what do we know about that? Well, that means f of x equals to 0. F of x equals to 0. Do we know f of x? Yes, we do. We know f of x. We calculated it. And what is it? We are now going to use the factorized expression, okay? Just to make things a little bit easier for us. So to use the factorized expression, the first one was x minus 2. The second one is what? Is 2x minus 7. And the third one is what? The third one is x minus 6. Like that, equals to 0. So that means we will have three values. And what are they? Well, the first one will be x equals to 2. All right, x-intercept occurs at that point. Then the second one will be x equals to what? 7/2, which is like 3.5. This is x/2. Let's raise it up here. x/2. And what would be the next? The next value is x equals to what? 6. Those are the values when the function cuts the x-axis. We call them x-intercepts. In fact, let me put it here, x-intercepts, because it's cutting at what? At 3 other points. Then for the y-intercept, we have the y-intercept, we have x equals to 0. So when is x equals to 0? Well, that means we find the value of the function when 0, x is equals to 0. In other words, where there is x, we write 0. So let's look through and we see the original expression. The original expression is this one here. Yes, this is the original expression. So when we put 0 for x, this will cancel, this will cancel, this will cancel. We are going to be left with what? Negative 84. So we put it down as negative 84. Like that. So that means the x-intercept is, you know, in coordinate form, we will be writing what? We will be writing 0 for x, What do we have for y? 84. Isn't it negative? Let's check. Yes, it's negative. So we put it here, negative. And also here, negative. Like that. So what else is there? Are we not yet done? I guess we are supposed to be getting done really soon. Yeah, all right. Just do these last two really quick. For which values x will, for which values of x, just have there, of x will the graph of the function be concave up? The graph of the function is concave up when, well, for which values of x? That one we have to get the second derivative first. We already got the first derivative somewhere. Let's see, where is the first derivative? The first derivative, when we were finding the turning points, the first derivative is right here. You see, this is the first derivative. Now we have to do what? We find the second derivative. So when we differentiate this for the second time, in fact, this other tool had refused and I wanted to, sometimes we need to have this one the other side. So this is the first derivative. I'm just going to do what? Going to see if it can accept to have this one right down here. This is 4.5. Is it 4.5? Yeah. Kind of like 0.5. That's the question we're dealing with. Oh, it has also refused. Fine. So there we go. Let's just get the second derivative. So we'll be having the second derivative of this function of x equals to what? Just check to and differentiate from up there, then we write the value. So the second derivative from here, when we differentiate 6x squared, we will be having 12x. And this will be what? 46. So we'll be having 12x minus 46. So let's just have it there. 12x minus 46 minus 46. Okay. So we have to equate this to 0 at the what? To find the concavity, the nature of the concavity, we have to equate this to 0. In other words, we will be having 12x minus 46 equals to 0. Okay, 12x minus 46 equals to 0. And so this was supposed to be equals to 0. We just put this equals to 0. That is how we find what? The values of x for which what? The function will be concave up. So when we do this, when we reach here, we now have to solve for x. So what's the value of x going to be? Because on the left hand side, we are going to be having 12x, and on the right hand side, we'll be having 46. So to find the value of x, we divide everything by 12. And so x is going to be equals to 46 divided by 12. Do we get a very specific value for that? Let's see. 46 divided by 12. It's 23 over 6. It's better that way. 23 over 6. 23 over 6, yes. So we conclude that for values of x starting from this one here, the function will be concave up. Okay, it starts from this and it will be concave up. So we put this starting from 23 over 6. Like that. Yes, that's what we have got. That is the value of x for which the function will be concave up. And the last question is determine the coordinates of the y-intercept of the tangent to f that has got what? Determine the coordinates of the y-intercept. Okay, determine the coordinates of the y-intercept of the tangent to f that has a slope of 40 and touches f at the point where the x coordinate is an integer. Now this is a long question. Just read it out and you see how long the question is. Well, it's also 6 marks. Now we are going to break it down. We do it like this. Determine the coordinates of the y-intercept of the tangent. So the first thing is, what is this tangent all about? Tangent is the slope. It helps us to find the slope. Okay, so that means we have to find the value of dy by dx. The good news is we already have the value of dy by dx, the derivative. They are also saying the derivative is equals to 40. So that means we have to equate dy by dx to 40. When we equate dy by dx to 40, then we solve for x. That's all. So let's do it really quick. So this is going to be, what is the value? We just have to copy because we had differentiated it already. So where is it? 6x squared minus 46x. Okay, 6x squared minus 46x. This is what? In fact, am I even labeling correctly? Yeah, this is now 4.6. Okay, 4.6. That's what we are dealing with. So they are saying the first derivative. That's what the question is talking about. F of x is equals to 40. That's what they're saying. And so what do? We just substitute. We be like, well, 6x squared, 6x squared minus what? You see, now I'm forgetting it again. 6x squared minus 46x minus 46x 46x plus 80 equals to 40. Let me confirm if the sign before 80 is a plus. Yes, plus 80. So this is what we are dealing with. So we just have to find the value of x from here. I guess this is something you can now handle. This is 6x squared. 6x squared minus 46x plus, not minus, plus 40. Okay, that is when we transfer. When we get this 40 and we bring it this side, that's what we are going to be getting, equals to 0. Now you can solve this. This is a quadratic equation that you can solve with ease. I'm just going to give you the final answer, which I did, and I got the first value of x as being what? The first value of x as being 1, because that is something you can now prove. Okay, and the second value of x. The second value of x as being 20 out of 3. That's what I got. You must get that value. X over 3. Yeah, so that is what have we got in this case? Well, wait. So determine the x coordinates of the y-intercept. Determine the x coordinates of the y-intercept of the tangent to f, the tangent to f. How do we even determine the tangent to f? This is a very interesting question. How do you determine the tangent to f? Well, to determine the tangent to f, we differentiate. Then after differentiating, we can substitute the x value if we want to find the gradient. Okay, we substitute the x value right inside there, and I had already calculated, and I had got, well, these x values, which I have just put, let me check again, x equals to 1, and x equals to what? And x equals to 20 over 3. We are dealing with the integer. We are going to ignore the 20 out of 3. That's what the question is saying. So we are going to find f of 1, okay? So let's find f of 1. What is the value of f of 1 going to be? F of 1 going to be a long calculation again. So let's see, long calculation here. What's the original expression? The original expression is, where are you? Yeah, 2x cubed. So that's what we are going to be doing, 2x cubed minus 23x squared. So what do you have? 2x cubed. 2x cubed minus 23x squared plus 80x minus 84. So for x equals to 1, what do we have here? We just substitute and we put 1 for that. And also here, substitute and put 1. And also here, we substitute and put 1. Yes, do that. Do that. Find that value. Otherwise, I'm just going to give you what I've already done. Okay, I'm just going to give you the value that I've already calculated. And what is that value? That's going to be the y value, which is what? I calculated and I got negative 25. I got negative 25. Yes. So you see, the thing we are dealing with right now, is that we have got now the point, and the point has got the coordinate for x being 1, okay, the integer 1, and the other one is the y being negative what? Negative 25. Yes, I've copied correctly. So now, what's that supposed to mean? That's then supposed to mean that from here, we can find the gradient, okay? We can find the gradient, and after finding the gradient, we can find y equals to mx plus c. You know, y equals mx plus c. So from this, okay, because they're talking about a tangent. A tangent is a straight line. It's a straight line, and since it's a straight line, it will be in the form y equals to what? Y equals to mx plus c. That's what we are now dealing with. Okay, so we have the value of x. The value of x is 1. And the value of y, okay, the value of y is negative 25. Can we find the value of c? Yes, we should be able to find the value of c. But do we have the value of m? M is the gradient. M is the gradient. So how do we determine the gradient? M is the gradient. So let us see. We now have y, we now have x. How about m? Let's see. M is the gradient. The gradient is dy by dx. So we say the gradient is going to be m. And how do you determine m? We just do this. We say m equals to the value of dy by dx. Where did we differentiate this? We differentiated it here. So you'll be putting 1 for x here and that. So from 6x squared, so this is 6 times 1. I'm just not going to write the whole thing now. Typing this thing, the equation thing is a very long thing to type. So I'm just going to put 1 there. So you'll be having 6 times 1 squared, okay? Minus what? minus 46 times 1. Yes, plus 40. Plus 40. Wait, is that what we are going to get? Is this? Is this? No, not this is not the derivative. I'm substituting in something else. The derivative is not that one. Yeah, the derivative is this one. This is the derivative, so that's where I'm supposed to substitute 1. So it's going to be, again, 6 times 1 squared minus 46. 46 times what? Times 1 plus 80. Plus 80. Yeah, this gives 40. So the gradient is 40. Just right away, just put it here. M is 40. So put it there and find the what? Find the value of C. And what is the value of C? The value of C is going to be, well, if you read this well, determine the y coordinates of, determine the coordinates of the y-intercept. That's what they're asking for, the C value. So we have y, we have m, we have x. Can we find C? Yes, we can find C. Let's just do it and we conclude with that. So it'd be like y, which is negative what? Y is here. Negative 25 equals to x, rather m, which is 40 times x. Do we have x? X is 1, like that, x is 1, you know, plus C, plus C. Plus C here. So what do you get from here for C? C is going to be negative 25 minus 40. And so from there, we conclude that C equals to what? Negative 65. Yes. That is it. The question was so long. Let's stop there. You guys got a question? If you do have a question, please send to me on WhatsApp. We have to stop here. Otherwise, thanks so much. We will continue later, and later can be used to mean tomorrow. So have a wonderful time and stay safe.